Welcome back to Hypotenmoose Kitchen, and we are looking at multiplication of fractions today. Jack, I would like you to multiply, or we'll think about it together, 2/3 times 3/8. So maybe as an example before we get there, let's do 1/3 times 1/4. We just did that one, and let's just take a look at what that looks like.
Okay. There's 1/3 going that way. And I believe this to be 1/4 going that way.
So you're dividing this third into quarters? Is that what's going to happen?
Yes.
Okay. So what is that overlap piece? Is that where the answer is?
The overlap piece is the answer. It is 1/12.
Because you can see that that's 1/4 of the third. And we could do it the other way as well. Could we do 1/3 of the quarter? Is the answer the same?
Yes.
Okay. Okay, can you get rid of that? And let's try the 2/3 times 3/8 and see where that goes.
There are 2/3. And there are 3/8. The overlap right there could be expressed in a few different ways.
Well, what was your first idea? The first idea was you wanted to have the 1/6 piece.
Yes.
Because you liked that idea.
The 1/6 could fit right there, but you can't fit another 1/6 piece on. You can fit half of one.
So you said the answer was
1.5 sixths.
1.5 sixths, which is pretty cool. We'll maybe write that down a little later. Okay. Take that off. What's another option?
Using 12ths, you can fit one there, one there. And it doesn't fit, but if you had this cut in two, you could put 1/2 there and 1/2 there, and that would be equivalent to 3/12.
Okay. Good. And then, what else could you do?
You could. This is 1/4.
Mm-hmm.
You could fit 1/4 there. You could put 1/2 there, and the other half of the 1/4 could go there.
Ooh. Really?
Yes.
Prove that to me using maybe one of the other smaller pieces.
This.
I don't know if I believe it.
An equivalent to 1/4 is 6 28ths.
24ths.
24ths.
Yeah, 6/24ths.
And we can fit
Sure, that makes sense.
6/24ths
Oh.
in the overlap.
So we have just done some interesting things. 3/12ths, 1.5 sixths, 6/24ths, and 1/4 are all equivalent, and they are all the product between 3/8 and 2/3.
Yes.
Thank you for your mathematics. And that, well, it doesn't quite conclude this. We'll just go back to the hypotenuse, but we will be right back. Okay, so what you saw Jack do in those few manipulations there was multiply 1/3 times 1/4. And what he did, I'm going to do as a sketch. So here's the one piece. And he laid his 1/3 piece. Probably scratching that out is not a good idea. But I'm just going to shade it. There's our 1/3 piece. He laid that out. And then he laid 1/4 vertically. I'll just change colors to do the quarter. So if we imagine where 1/2 is, and there's 1/4, and there'd be the other quarter. And he laid a 1/4 piece going this direction. And what he could observe is that the times sign acts like an of. So we have 1/4 of, or we have 1/3 of a quarter, and in this case you can kind of see that I've got the quarter piece is this purple, and so I've got 1/3 of it, because it's, if you imagine the whole thing is divided into thirds in the horizontal direction. Or we can reverse it and take 1/4 of 1/3, and there we have this third piece divided into 4 equal pieces in the top. And one of them is this corner. So what is the area of that corner if the whole is this larger rectangle? Well, I can see that there are 12 equal pieces here, 3 rows of 4, or 4 columns of 3. So I can see that that piece is equal to 1/12. You may have seen this done in other ways as well. 1/3 times 1/4 is equal to 1/12, and you may notice that the denominators get multiplied. Okay, we established that kind of thinking with multiplication, and then we went to our original question, which was this: 2/3 times 3/8, and let's see how that process will help us here. Here's our original thirds here, and this time we have 2 of them shaded. And then Jack said, I want 3/8 of that. So to divide this thing into eighths, I'm going to run a horizontal at the half mark. I'm going to run, no, a vertical rather, some at quarter marks, and then I'm going to half each one of those quarters to make eighths. So I am using my visual reasoning in a sketch, but from what I know from the kit as well. Then I'm going to shade 3 of those eighths. So that's what I have here. And so what Jack noticed is all of these pieces get covered. So I'm going to take a look at what that is in a fairly symbolic way. He's taken a look at all the ways he could express that. And he showed you that with pieces. I'll show you that in another way as well. So I can see that if I were to count all the possible pieces and only 6 of them are shaded, I can see that I have 3 times 8 possible equal pieces. This row seems a bit bigger, but it's supposed to be the same size. So I have 6 out of 24 pieces shaded. Notice that that's the product of 2 times 3 and 3 times 8. I can simplify that in a few ways if I'm working symbolically, and that is to notice that 6 is a factor of both 6 and 24, and that means I might divide by 6 and divide by 6 to get a lowest terms fraction of 1/4. I think Jack showed us that in a visual way. He also noticed that this could be expressed as 3/12 by showing us those green pieces. And if you see here, a 12th would be 2 of these 24s. There's another 2 24ths and another 2 24ths. So we know that they're equal because we saw that visually. He also mentioned something kind of unusual. 1.5 sixths, which is not commonly expressed. We don't ordinarily say 1.5 as our numerator and something else as our denominator. But if you were to run those things through your calculator, you would see that they come to the same decimal as this 1/4. And if you have any knowledge of how many times you multiply 1.5 to get 6, you know that it's 4. If I divide both top and bottom by 1.5, I will get 1/4. Thanks.